Hello friends, my name is Mohsin Mulla and I welcome you all to my channel Mohsin Mulla Interactive Tutorials. And in this video lecture we are going to see about the introduction to integration. Okay, so this is a part of prerequisites required for the subject signals and systems that you are going to study in this semester. So here most of the time we are going to use calculus a lot of time for solving some of the important examples based on signals and systems. So when we want to solve the example which depends upon the simplification of derivative term or the integration term, so at that time it is required for us all to remember some of the basic conversions from you can say derivative to integration or integration to derivative. So for that we need to know how integration is performed and how the derivative is performed on the given function. So now let us begin today's lecture with introduction to integration. So now what is integration? Basically integration is to find the area. Okay, so if I want to explain you in a simple words, suppose if you are asked to determine the area of certain shape. Okay, suppose there is a shape like this and it is having a known, you can say the height as well as the known width, then the area will become directly height into width. Okay, so that you know clearly. So this is for the known typical shapes. But suppose if the shape is not exactly a rectangular type or square type, but it is a random shape. Suppose if the shape is like this, so now here the shape is completely changing. So in that case how are we going to determine the area? So for this particular type of shapes we require to use integration. So integration is nothing but it is cumulative addition of the pieces of that particular shape, so that in the end when the area is to be evaluated all these small pieces are added together to get a final area. So like this the small pieces are made and these pieces are added together. Now for adding these pieces, so two things are required. One is the width. Okay, so whatever width we have as well as the other one is the height, or here the height is because of the function, so whatever function it is varying with. So whatever shape we are going to have, it will have a typical type of shape, so that shape is called as f of x. So if I take here x as the variable, then f becomes the function. So here this you can say the width will be equal to, here the width will be equal to dx times, therefore so this height can be represented as f of x and the width is d of dx. So therefore the overall area can be obtained in the range from starting, say starting point is 0 and we want it to up to certain particular range, say here up to 10. So 0 to 10 x equals to 0 x equal to 10, in that range we are going to evaluate height into area. So it is nothing but it is going to add for all the instants between 0 to 10. Very smallest instant that you can imagine will be added and its area will be evaluated here. So therefore finally we can write it as f of x into dx. So this is the representation of the integration. So evaluation of this will give us the overall area. So here f of x indicates what, the height term, and dx indicates what, the smallest width term. Okay, so to get the total width we have to add from 0th instant to x equal to 10th instant. So all the bits are added together to get the total width. So that will become x here, and all the height will be evaluated in the single term. So that will be nothing but based on each instant magnitude we are going to get it. So that will be f of x represents the height at a particular value of x. Okay, so now that is what is the integration is all about. So now let us see this with the help of a simpler representation over here, which is shown in this particular uh, figure here. Okay, so if you are able to see this figure. Okay, so now here what we are going to do is, suppose there is a change occurring and it has got a shape like this, and we are expecting to get the area under this curve. So to get the area what we need is, one width is required, another one is the height. Okay, so therefore we are going to use the small width del x, and we are going to add cumulatively all the area. So here this much is the area of this, and del x times this much height will be the area of this block, and similarly here Here all the blocks are added together. Okay, so finally we are going to get the area, but this is going to give us area, but that area is not going to be accurate one. As you can find, there are certain areas which are not, you can say, occupying the entire area under the curve. Therefore this area will be excluded from the total area. As well as here, if you observe, there are extra areas being added which are not under the curve, so this is not going to give us the accurate result. Therefore we can try to obtain the accurate result by making the size of that slices even smaller. Now in the second figure that you see over here, okay, so in this second figure that you see over here, so we are going to make the del x value smaller than the earlier, so because of which what will happen, so now you can see more amount of area is precisely covered under the given curve here. Okay, so more area is covered under this particular curve, but still there are certain areas here which are not completely occupied, and here there are some extra areas. So now again, this is not going to give us the accurate result that we are expecting to get. So now what is the solution then? So we have to make the width so small that it approaches the zero. Means the width is very very small, just a single line you can consider. So only that line will be giving us the particular area of that line we have to obtain here, depending upon the variation with respect to that f of x function. So therefore if you going to draw lines together adjacent to each other cumulatively instant by instant, so you are going to cover the entire portion under the curve like this shown here. Okay, so once you have this, then you can directly obtain the area by using the integration of the function here. So that is a lot of adding we have to do, but that adding is done with the help of a integration. So now you might think that how are we going to do the addition for such a we can send so many number of instants. So we do not know the exact number here, it might be 1000, it might be 1 lakh, anything, any number is possible here. So it will become easier since we know that integration and derivative are reverse of each other. Okay, so whatever we are going to do the integration, the result will be like original function of a derivative. So for example here we are going to take integration of 2x. So here f of x is 2x. So now if f of x is given as 2x, okay, or the here integration we want to obtain, so what we are going to get is integration of this 2x times dx is going to be equal to x square. How did we arrive at this particular term x square plus c? Because here when we obtain the derivative term, so we know that for the derivative term of x square, it is going to be to x. Therefore if you are obtaining the integration, it is reversal. Okay, so 2x integration will give us x square. Okay, so here integration and x square integration derivative term is going to give us 2x. Now why we are taking the constant c along with that? So that constant c is because a lot of functions can lead us to the value to x in case of a derivative. So here if I take x square plus 2, still we are going to get the derivative as 2x. If I am going to take x square plus 99, even then we are going to get the same. Even in the case of negative value, say x square minus 10, I am going to get the same derivative of 2x. Therefore this constant c will become 0 in case of derivative, but in case of integration it will have to be existing. Therefore we are going to take that c also in when we are obtaining the integration. So here is the final notation for that integration. Okay, so it is integration of 2x dx is x square plus c, and here is the explanation why we need to take that plus c. Okay, so this is what about the integration. But also integration is not only used for determining the area, but it can also be used to determine the volume of certain space. Okay, so therefore here how we can obtain the volume, so that also can be understood here very easily with the help of a simple analysis over here.